Hi everyone. Today we are starting section 4.6, Limits at Infinity and Asymptotes. In this section, we are going to study how functions behave as x becomes very large or very small, meaning as x approaches infinity or negative infinity. These ideas are really important because they help us understand the end behavior of functions, identify horizontal and slant asymptotes, and improve how we graph functions using limits and derivatives. Let's start with the idea of limits at infinity. Here we are asking, what happens to a function when x keeps increasing forever? Or what happens when x keeps decreasing forever? We say, if x gets close to a number O as x approaches infinity, then the limit as x approaches infinity of f of x is L. Similarly, if f of x gets closer to a number L as x approaches negative infinity, then the limit as x approaches negative infinity of f of x is L. If you look at the graph here, you can see that the function getting closer and closer to a horizontal line as x moves left or right. That number is approaching, that's the value of the limit at infinity. In this case, L is 2. So we say the limit of f of x as x approaches infinity is 2. And the limit of f of x as x approaches negative infinity is also 2. Let's translate that into plain language. As x becomes very large, the function f of x gets closer to L. And as x becomes very negative, the function f of x also gets closer to L. So basically, we're looking at the long-term behavior of the function.